So welcome to the lecture 3 of APRG. I guess you had the tutorial, the first tutorial. Did it go well?
Yes, sir. I don't think there were a lot of questions. Like the tutorial was done in like 15 minutes.
I see. But people did want that tutorial, correct? So I don't understand why there were no questions.
So there were some questions, but then like I think most of them got covered inside of 15 to 20 minutes. So then after that we were done.
Fine. Agreed. Okay. So let me start the lecture. So what is to be done in the first assignment you posted? Has the first assignment been posted or just the 0th assignment? As far as I know, only the 0th assignment has been posted. Correct?
Yes, sir. I'm talking about the 0th one.
So 0th one was just to for you to check how to submit assignments, how to, and so on and so forth. Correct? So it was just a practice run. It will not be graded. Is that clear?
Yes, sir.
Actually, I didn't get what to be done in those two problems. Like, what?
So they were very basic problems. I think one was taking the product of two numbers, and this, I don't remember the other one. They were just default problems, so that it was just to introduce you to the process of submitting your solution and checking the answers, checking the in the automated process to check the this thing, correct? Just to introduce you to the process. You didn't have to do anything great in order to attempt that assignment. Okay?
Okay, sir.
Okay. So let me go to the...
Sir?
Yeah, tell me.
Will there be classes every Friday too?
Friday? No,
Yeah.
why?
You mailed something, right?
No.
Was it from some other professor probably then?
I didn't mail anything about Friday. So we have classes only on Tuesdays and Thursdays. And if there are tutorial sessions, they'll be extra, correct?
Okay.
So so let me get down to the lecture now, correct? Unless there are more questions. Okay. So we were talking about Python, and we were talking about variables which are called names in Python, names and values, correct? And we were talking about immutable data types. We were talking about data types, only values have types. Names do not have types associated with them. The same name can be used with multiple types, correct? So you have integer, float, Boolean. These are the basic types, and they are, yeah, tell me.
Sir, are you sharing the screen?
Yeah.
Oh, sorry. Now do you see the screen?
Yes, sir.
Okay. Thanks for telling me. Yeah. So okay. We have these names and values, and we were talking about immutable data types. The basic data types are all immutable, and immutable updates are like when we draw the figure, you have a name X. So these are names and these are values. So this is a value V, and if you change X, if you change the value, V will go to V prime, correct? So for example, if you have x is equal to 1, and then you say x is equal to x plus 1, a new value which is 2 will be assigned. So here b is equal to 1, b prime equal to 2, and this will be changed to this, correct? So this is in immutable data types. In mutable data types, the value itself is changed, correct? Value altered, correct? So for example, if you have so again I draw this name versus value thing. In the namespace you have a list L that points to say something comma something comma something, and you update a particular entry of it. So this points to something, this points to something else, and so on and so forth. For example, this could be 1, 2, 3, 4. And now if you change L1 is equal to 3, then the list would become, this would start, instead of pointing to 2, it would start pointing to 3, correct? On the other hand, strings which are like lists but are different in this sense that strings are immutable. So strings are lists of characters, only thing they are strings are immutable.
So in the previous example, if we ask for print x, then what would be printed, 1 or 2?
After so here you print x, it will be print x would print 2, correct?
So like I didn't get the sense like what it means when it is immutable. Like the
Immutable
value
means that the value 1 is not changed. What is stored in the variable is changed. So you can think of these values 1, 2, 3, 4 living in the value world, and x is pointing to 1. Now it starts pointing to somewhere else which contains 2, correct?
Okay, sir. Okay.
On the other hand, in list, when you have a list, you can change the thing that L points to. So here if you do, tell me.
Sir, here you're assigning, you're reassigning the value of one particular element of the list. Right? What
Yes.
Can you reassign the entire list itself?
Yes, you could do L is equal to something else, A, B, something like this. Yes, and that would change L itself to point to, in this case, L would now start pointing to this thing. A, comma B, correct?
Okay, sir.
Correct. So that is of course an option, correct? Now strings are immutable. So if you say, if you have a string like something, and you want to change it to something else, let's say somewhat, how would you do that? You cannot say, I will change this part here, because lists are immutable, correct? So you can change some, you can do, so let me take a smaller example or whatever. S is equal to something, and then you use something called slices to extract part of S. So you say, and I will explain this in 1 second. So you have something. So this is 0, 1, 2, 3. So you do S 0, 3, 0, 4 plus what? And this S is equal to S 0, 4 plus what? This would evaluate to somewhat, correct? So what is this 0, 4? It says that you take the a substring of this string which is indexed by indices from 0 to 4 minus 1, correct? So this is shorthand for S0 plus S1 plus S2 plus S3. Correct? This entire thing. Correct? Plus is, of course, the concatenation operator. Are you with me?
So the last number will not be included, right?
So I have 0 to 4. Last number will not be included.
Okay.
So it goes till len minus 1. I mean, so if you do something like Si colon j, this is shorthand for Si plus 1 dot 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 till S of j minus 1. Correct? Correct? And this works for lists also. So if you have a list like L1, 0, 1, 2, 3, and you do L 2 colon 3, what would it give? Tell me. What would it evaluate to?
The 2.
It would just evaluate to the list containing 2. Correct? And so this is equivalent to L2. Similarly, if you do L1 colon 3, it would evaluate to 1 comma 2. Correct?
Sir, shouldn't L2 be in the list brackets? Because if you do L2, we only get the second element, but here we're getting the second element inside a list.
Yes, so this is also a list. L2, yeah. Sorry. I should have said this. Sorry, my mistake. You're correct. Correct. So, so L1 colon 3 is basically the list element, the list consisting of L1 and L2. Correct. And because it is equivalent to this, this essentially copies the things that are contained inside the list. So this is a copy of the list. Okay. Are you with me?
Sir, what do you mean by copy?
So that's a good question. So for example, if you have a list L is equal to 0, let's say 0, 1, 2, or let's say 1, 0, 1, 2, 3. Correct? Just for this thing. Correct? And now you say, so how do we represent it? It will be represented by saying that you have this name L and the value, which is a list, and the 4 elements here point to 0, 1, 2, and 3. Correct? Now, if you do L1 colon 3, correct? This is a new list, correct? Which would point to the things contained in there. So this would be a new list, which would point to basically the 2 elements, which are this and this. Correct?
So sir, like is there a new list created in the memory? Is that what you're saying?
Yes.
Okay.
So for example, so this is what is called a slice. Correct? I should have said it earlier. So basically Li colon j is equivalent to Li comma Li plus 1. I think I wrote it down somewhere. L j minus 1. Correct? And so it's a new list containing the same elements, the elements from I to j minus 1. Correct? And you can, if you want, you can say, so there is some slightly counterintuitive thing. you can change this thing. So you can say, suppose L were this list, correct? Now you say L of 2:3 or 2:4, correct? 2 element list from 2 to 3. You change this to be equal to 5, 6, 7. So what will happen? Tell me.
Shouldn't it give index out of bounds?
Huh?
Shouldn't it give an error? Because like we don't have 3, right?
No, 2:4 changes the part between 2 and the 4 minus 1th index to this list. So this would evaluate to, so L now evaluates to 0, 1, and 2, 3 is changed. So 5, 6, 7. Correct? Think of this as a more complicated version of saying L2 is equal to 5. Correct?
Sir, sir, I have a question here, sir. Sir, so let's say your let's say L is 0, 1, 2, and 3, and you have
let
now,
me write one thing. L is equal to 0, 1, 2, 3. Yes.
now you said L 2:4 equal to 5, 6, 7.
Okay. Yeah.
Now let's say we give the command print L 2:4. What will happen here?
This would print 5, 6, 7. No, sorry, my mistake. So it would print 5, 6, 7. Yes. So when you, if you do this, what would happen to L? L evaluates to 0, 1, 5, 6, 7. Correct? Do you agree?
Yes, sir. Yes, sir.
And now you L2:4 now evaluates to again to 5, 6, 7 because that's where you set it.
But 2:4 will print the elements
Sorry,
of
2:4 will print 5, 6.
yes, sir. So this is where I have a confusion, sir. So
Sorry, my mistake.
so let's say L is assigned to some memory address in the computer, sir. Where will L2:4 will be?
So L2:4 is in the original list. It will start from the second index and go till the 4 minus 1/3 index. Okay, now you have changed it. Now it's a new list. And once you do L2:4, then it would do whatever is in the 2,4 thing. So this evaluates the new version of L, correct?
Yes,
sir, related to his question right now, sir, L2:4 should take 2 elements, right? But you're giving a list of 3 elements.
Yes. So you can even give a list of 0 elements. You can give an arbitrary list. So you are not constrained. You can say Li:j is equal to empty. That will just delete that part. You can say Li, so for example, you can say L2:4 is equal to empty. Then that means that you would get, what would you get? This means L evaluates to L equal to 0, 1. Correct?
So, sir, in the example you've given, so we can access L5 now. Is that what you're saying?
No, L5 you cannot access. In this example, no? Or in
So like the original one, L2:4 is equal to 5, 6, 7, and then 5, 6, 7 is 3 elements, right?
5, 6, 7 is 3 elements. So this is 0, 1, 2, 3, 4. L5 is still not accessible.
Sorry, 5th element, I'm sorry. 4th.
L4 you can access. Yes. Yes.
So if instead of 5, 6, 7, we do 5, 6, 7, 8 or 5, 6, 7, 8, 9, then we can go ahead as well. Is that?
Yes. If you do L2:4 is equal to 5, 6, 7, 8, 9, correct? Then L would evaluate to 0, 1, and then 5, 6, 7, 8, 9. And now it's any regular list consisting of 4 plus 3, 7 elements. So you can evaluate from L0 to L6 and from whatever, L minus 1 till L minus 7. Correct? All these are defined. Correct?
Okay.
So somewhere we are using single equal to and somewhere we are using double equal to. So when do we?
So single equal to, this is not a good usage. What I meant was that this single equal to is always assignment. You assign a variable to something. You assign a name to something, correct? Or some object to something else, correct? While this is just for, this means that this is equality, checking for equality. So remember, I should have written this in comments. What I meant was, if after this stage, so you understand, no? If I want to
Like
write
this is an operation, like it will output a boolean. Like if we do double.
Yes, that's correct. So this is equality checking. This is the Boolean equality test. Correct?
Yes, sir. Thank you, sir.
Okay.
Sir,
Tell me.
It's correct. That's correct. It's fine.
yes, sir. Sir, I'm confused as to the out of index cases, sir. So let's say we have an empty list.
We have an empty list. L is equal to empty.
And then now we say print L of 2.
That will give an error.
That will give an error. But if
Yes.
we say print L of 2 colon 4.
That will also give an error.
So will it?
I would think so.
It seems
Because
to me
2
that
colon
it
4
gives
is not
gives an empty list.
Does it?
Yes,
Can
sir. The
somebody
out
try
of
it?
index case.
Can somebody try it out? I think it should give an error.
Sir, what are we supposed to try out? Could you repeat?
So the question is, if you take L to be an empty list and try to print L2 colon 4.
Sir,
Huh,
it doesn't give an error.
So it gives an empty list.
it gives an empty list. And if you do L is equal to 1 and do print L2 colon 4. Is it
Still an empty list.
okay? Okay, fine. So then maybe the natural conclusion is that when you take a slice, you can take any slice of any list, even if it's not this thing, and if the range it's out of range, then so you are saying if the indices are out of range, you don't get an error, then you get an empty list. Okay, that's something I didn't know, but yeah.
Also, sir, if they're partially out of range, then the intersection will be given.
Then you get a list that is partially in range. By that, it means that if you have L is equal to something like 0, 1, 2, and you give L 3 colon 4, 3 colon 5, you would get this evaluates to 2. Correct?
It will be empty list, right?
Sorry.
Should be empty.
The 2 colon 5. Sorry. Yeah. L 3 colon 5 evaluates to the empty list. Good point.
Sir,
But if we access individual elements, then it will give errors, right?
But if we access individual elements, then that gives an error.
Sure. So if we put L equal to L1 before changing L2 to 4, and then if we ask L1 of 2 4, then will it change the value of L1?
So you are saying what happens when L2 if you do L2 colon 5 is equal to, or L3 colon 5 is equal to something else? Is that what you are asking?
No, sir. So we declare L equal to L1. L1 is another list, and
L,
then after changing
yes,
the
slowly,
value of
slowly. L is equal to L1.
L1, and then we change the value of L2 4 equal to something.
L2 colon 4 is
4 is
equal to something else. Then
yes.
the value of L1 also changes.
Okay.
You can see this from this, that you have L and it's pointing. So you have L1 which points to a list. Let's say 0, 1, 2, 3, 4. Correct. And you say L is equal to L1, so that points to this. Now you change L2 colon 4, that slice of L. So that's this slice, and you change it to, let's say, I don't know, 5, correct? Then instead of this, you would get L being pointing to the same list with this part being changed to 5, correct? And L1 also points to the same thing, so you have this, correct? But on the other hand, if this occurs on the right hand side, so if you say L is equal to something like this. So let's one second. If you say L2, sorry. L2 is equal to L. So now the list is 0. So now the list evaluates to 0, 1, 5, 4, correct? And you say L2 is equal to L, let's say 1 colon 3, correct? Now if you change L, then L2 will not change, correct? You do L, so this evaluates to 1, 5, correct? Are you with me?
Yes, sir.
And you say L 0 is equal to 3. So this means that L evaluates to 3, 5. But L2 0, sorry, L0 is equal to 3 means that L evaluates to what? I can't find any TVs to open apps nearby. So L0 evaluates to so L evaluates to 3, 1, 5, 4. And now if you print L2 0, it will still remain, L2 0 still remains 1. This one. Do you see my point?
Yes, sir.
So, so on the left hand side, a slice is different from a slice on the right hand side.
So when we do L2 equal to L1 colon 3,
huh?
Then it creates a copy of L1 colon 3, right? And L2
Yes,
points to
it
that
creates
copy.
a slice of of L from 1 colon 3 and assigns it to L2, correct?
Okay. So if we change L1, suppose, then L2 won't be affected.
L2 will not be affected. If you change L or L1, L2 won't be affected.
Okay, yeah. Thanks.
Correct. Okay. So, tell me.
So could you repeat what you said about L2 not being affected if you change L or L?
So what I'm saying is you assigned L2 to be a slice of L, correct?
Yeah.
Which means that the picture looks like this. L was pointing to this object. So this object, correct? And now you assigned L2 to be a slice of this. So which slice? This slice, correct? So L2 points to a new thing, 1, 5. And remember, this 1, 5, these are immutable elements, 1 and 5, so it's the same 1 and 5, correct? That this pointed to. But I'll give you an example just now where it's slightly different. So, so now if you change, so now L2 points to a new list, correct? Which has nothing to do with L.
Yeah.
You get my point? So the new list is separate from L. And now if you change L, it will not be reflected in L2. If you change L2, it will not be reflected in L.
Okay, yes.
Correct? But on the other hand, suppose you have, let's take a new example. List L is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. It consists of a list of lists, correct? Now, if you do L1 is equal to L 0 colon 1, correct? So what would L1 evaluate to?
Just 1, 2, 3.
To this 1, 2, 3, correct?
Yeah.
Now, if you change L1 0, 1 is equal to -1. Okay. Now, and you print L, what will it print? Tell me. 0, 0, sorry. 0, 0. 0, 1 will give an error because there are just one elements in this. So 0, 0 will give an error, but L1 0, 0 is equal to -1. Then L1 will evaluate to L1 will be equivalent to -1, 2, 3. That's clear, no?
So 0, 1 shouldn't give an error.
0,
1
1
would
will
point
not.
to 2.
Yeah, sorry. Why I'm getting confused. So yeah, 0, 1 will point to 2, correct? Yeah, but let's take this example. Yes, you are correct. L1 0 is this list, and then this has, of course, more than 2 elements. So, or at least 2 elements. Therefore, it has L01 is defined. But let's do this, correct? That was not the point I was illustrating. So what will print L give? Tell me.
So will it give the original L? I mean, because you're not.
No. It will give -1, 2, 3, 4, 5, 6, 7, 8, 9. And why is that so? Because see, you have this list L that points to that pointed to a list which had 3 lists, which contained 3 lists, correct? And these were in turn, this was pointing to 1, this was pointing to 2, and this was pointing to 3, and so on, correct? Now you made a copy of L0 colon 1, correct? Correct? So, in that copy, you still point to, so L1 now points to a list that contains, no, this is not the correct diagram. L1 now points to a list that contains one element that points to this. Correct? So both of them point to the same object. And now you are changing this 1 to -1. It will be reflected in L. Do you see my point? Are you with me?
So I have a doubt. So when you change 1 to -1, wouldn't the pointer from like L1 just shift to another block instead of changing that list? Like,
sorry?
So if 1 is changed to -1,
One
it
is
should,
changed to
the pointer should just move right to another block. Why is the block itself changing? Like -1, 2, 3. Why is it becoming -1, 2, 3?
So this part is clear now. This part up till this point.
Yeah.
So you are changing the value contained inside a list containing inside a list, correct?
Yeah.
But so the point is when you do this, so the point is when you do this L0:1, this is the critical step. At this point, you made a copy of the list, but the elements pointed to the list you did not make recursively a copy of. You do not say that if L points to something, correct? You do not make copies of these elements that it pointed to, correct?
Okay.
You just took the thing that is from L0:1, namely this list, and made a copy of it. So you created a new list L1, which contained one element that pointed to the same thing that this thing, correct? So if you change L1, nothing will change. If you do, for example, L10, at this point, if you do L10 is equal to, I don't know, -2, 2, 3. Sorry, L10 is equal to -2, 2, 3. Then what will happen? L1 will change to L1 will become -2, 2, 3, but L will remain unchanged. But because you had changed an element inside this, the thing that was being pointed. So am I clear?
Yes, I think till now it's fine.
It's fine, huh? Does anybody have doubts here? If so, tell me.
So will you tell again?
So I'm saying when you do when you do this, you make a copy of the list, of a portion of the list, a slice of the list, correct? But you don't make copies recursively of the things contained inside that list. So if you have mutable elements inside the list, you don't make copy of that element, and if that contains another mutable element, you don't make a copy of that element, and so on. You just make a top level copy of L or some portion of L, correct? Do you understand?
Yes, sir.
So now, so this is what the picture looks like. L1 is a new list which has one element which is the same as, which points to the same element as pointed to by the zeroth element of L. And now if you change things here, it will be reflected in L. If you change things in L1, it will be reflected in L. If you change things to which this points, essentially. If you make a change here, it will be reflected in here. But if you change this altogether to something else, then that will not be reflected in L. And that's what I'm doing here. Do you see my point?
Yes, sir.
Okay. So,
Sir, so just to be clear, if you change one particular mutable element of L1, then the changes will be reflected in L. Whereas if you reassign L completely, then the changes will not be reflected.
yes. So if you in L is a list, correct? L contains objects, correct?
Yes, sir.
Values, correct? Those values will not be copied when you make a slice of L. new copies of that those values will not be created. If they are mutable, you would just the slice would point to the same values that are contained originally. Am I making sense? Okay, so you think about it. If there are doubts, ask me later, correct? Now, there are also some shortcuts that you can use. So for example, you can write L colon I to denote, or L colon J to denote L0 colon J, correct? This is a shortcut. You omit the 0 and you get everything from L0 to J. Similarly, if you you can write L I colon len of L, correct? And that no, sorry, I should have written it on the right side. So L I colon is a short form for this, correct? And realize that len of L is one longer than the name of the list. That's why we want, that's the reason why we have this -1. So len I colon J will basically go from, will contain is equivalent to L I till L len L -1, correct? Am I making sense? Okay. And finally, you just have L colon, that's the complete slice, and it stands for L0 colon len L. And this is used to make a copy of L, a complete copy of L, not just a portion of L, correct? So it's called a complete slice. Are you with me?
Yes, sir.
Yes, sir.
Okay. Now, or full slice, maybe it's called a full slice. So when you make a full slice, it's just a copy of the list with the values inside being the same as the values contained earlier, correct? And you can delete, you can, like we said, you can say, if you say L colon is equal to something, so L was equal to 0, 1, 2, 3, 3, L colon is equal to this, then that means that you make, or just 1, then this means that L evaluates to, L is equivalent to 1, correct? And so on. So this kind of shortens the slice, and you can make it, you can delete a slice also, you can delete the entire list, all the elements contained in the list by saying L colon is equal to the empty list and so on, correct? Now, sorry. So, so now there are many functions on strings and lists which are useful.
Sir, your screen is not being shared.
Oh, 1 second. I'll just. Now is it being shared?
Yes, sir.
I don't know why it disappeared earlier. Yeah. So strings and lists have many functions associated with them, and you should look up the docs to check them out. and I will just explain some of them. So len of L we have already seen. There is also L dot append a value which is equivalent to L is equal to L plus value. The only thing is that that's almost equivalent to, correct? Yeah, so this does it in place, it changes the value of L, and here it makes a copy of L, which is L plus val, correct? So it creates a new thing which is L plus val and assigns it to L, correct? Correct. And similarly, there is L dot extend L1, which is almost equivalent to L is equal to L plus L1. These are in place functions, correct? So so any questions so far? Okay, let me go on. So we have seen some functions associated with lists and strings and basic data types. Now we come to control flow. So that is basically your conditional statements and way to write loops, repetition, correct? So so notice that in a program you have a sequence of instructions, and the basic instructions we have seen are so the basic instructions are assignment, which is just name is equal to value, name equal to expression, where expression evaluates to a value, correct? And now we are seeing some more complicated things like conditional statements, and repetition loops, correct? So what are conditional statements? They are basically thing of the form, expressions of the form, if some condition, then some block of statements, else some other block of statements, correct? So are you with me? We saw this as similar things in the GCD program we wrote, correct? So you say if x is greater than 0, then do something, else do something else, correct? So here notice that the conditional statement x is greater than 0, you can use shortcuts for it. So you can say that 0 is of course, so false is of course, no, sorry. So if you give it a value false, then you would land up in else, correct? So similarly, if you give it a value 0, you would land up in else, and there are some equivalent things which are treated equivalently as false. So false is equivalent to 0, is equivalent to empty string, is equivalent to empty list, and is equivalent to none. And we will see none later. Everything else evaluates to true. all other values evaluate to true. Correct?
Sir, can you please repeat this question once again?
So I'm saying, if you say, if 0, then do something, else do something else. Correct? So then tell me which one will be executed. Then the
Sir,
else
else
will be
is-
executed. Correct?
Yes, sir. Yes, sir.
And similarly, if you put this empty string, then this else will be executed. If you put this empty list, the else will be executed.
Okay,
And,
sir. Okay, sir.
correct? And if you put an expression that evaluates to any of these, the else will be executed. Correct?
Okay, sir. Okay, sir.
Correct? That's all. Correct? And there is also multi-way this thing, if then else. So you write if some condition 1, then do something, elif condition 2, do something else, elif condition 3, do something else, and finally you say else. Correct? So elif is short for else if keyword, and you can structure this like this. There is also, I believe, now a switch statement or case statement, whatever you call it, in Python, but I've never used it. So you can see in Python 3.9, I believe there is a switch statement, or 3.10, something like that. Correct? So now coming to loops, we have basically 2 types of loops. One is the for loop. So loops, you have the for loop, which says for name in something, do something else. Correct? And this something might either be a list or might be something like something what is called an iterable. So something like range 0:10, something like this. Okay, which is not exactly a list, meaning every time you execute, so every time, so for name in, so if you write for I in range 0:10, this will be executed from 0 till till 9, correct? 10 minus 1, as usual for lists. And in every iteration, it would evaluate this range. It will start the evaluation of the range thing from the value that was there before. Correct? So it doesn't. So if you say something like for I in range 0:1 million, it will not first create a list containing 1 million entries or 1 million minus 1 entries and then start evaluating. It will do it. It will on the fly create that, take out one element. It will iterate over this. Correct? Am I clear?
Yes, sir.
Okay. The other loop is, so this was for loop for I in range, for I in some iterable or list. You can of course write for I in 0, 1, 2, 3, and this will go from for 3 times. Correct? You can also say for I in range, in list of range 0:10. Correct? And this would create an explicit list from this range 0:10. So this would evaluate to 0, 1, 2, ... till 9. Correct? Am I clear? This just makes it slightly more inefficient, or somewhat more inefficient, because you are first creating a list, and if you're range is very large, then you might not want to do that, correct? But you can do it. You can list the thing in some order. In the order it is generated. So this is the first type of loop. The second type of loop is while. So
Sir,
while, tell me.
So instead of 0, 1, 2, 3, can we put A, B, C, D for I?
So yes, you can put anything. You can say.
Okay. So I will take A first, then B first, second.
Yes.
Okay.
It is in the order. So if you say A, comma 1, 2, 3, comma 56, comma something, correct? You can say this, print I. Correct? So it would first print A, then 1, 2, 3, then 56, then something. Correct?
Okay, sir.
Okay. So while condition is another type of loop. So it's almost clear how it would run. While the condition is true, it would evaluate cond and the expression condition and check whether it's true. If it's true, it executes the rest of the statements, and then it comes back and checks the condition is true, and so on. Correct? And so those are the basic things. We will get into more fine detail of this like later on. But right now, these are the two basic loops. And functions, then we come to functions, correct? So,
Sir?
Tell me.
So could you repeat while, like what does while do exactly?
So it says it will check for condition. The condition should give you a Boolean expression or something. So it's like it should evaluate to either one of these things to any value, correct? If the value is one of these, it will exit the loop. Otherwise, it will go to the next iteration.
Okay.
So for example, you can say while 1, do something. So it will always execute this, correct?
Yeah.
But the better way to write it is, of course, to say while true, because that's what you mean, correct? Okay. So now we come to functions, and and I wanted to cover some more things. So the class ends in 2 minutes, correct? What is the time for the class? Till what time?
It is 4:45.
4:45. Okay, so I have time.
Sir, sir, how to break statement in loop in Python?
So break and continue. So you try it out, correct? So it's an easy exercise. I leave it to you to try it out. How to so write a loop inside while and try break and continue and see what is the effect. Correct?
Okay, sir.
Okay.
And like in for, can we also write I in list 1 and in list 2? How to write that?
Sorry?
For I in list 1 and list 2.
Or in list 2, or and in list 2.
And in list 2. So the intersection. So how to do that?
So
like,
you would have to take the intersection of the lists, correct?
Yes.
So I mean, if the lists are not sorted, it won't be easy. And there might be no way to sort. Tell me.
Oh, we can't directly write that for I in L1 and L2. So
no,
that is intersection.
That's not easy, because that's not possible, because when you do for I in something, it takes the values in the list successively And in the other list, there's no guarantee that they would occur in the same order or in any order. So such a statement is not provided in the language. On the other hand, if you just want to do OR, then you can take, then it should be easier, correct?
Okay, so then for I in or L1 or L2, that works. That should work.
No, that also does not work, but
Okay.
I'm saying that should be easier to implement.
Okay. So we'll have to create another union function or intersection function.
Yes. And you can, or you can just write two loops for I in list 1, for I in list 2. That would go over this thing. But of course, if they are common elements, then that will not help. Correct? So assume, yeah. So there's no simple way to do it in either case. Correct? Okay. Yeah. So functions, when you have, so how do you define a function? You say def f, and then a, b, c, d. These are the arguments, correct? And you don't, of course, specify types with them. You just give them names. So these are names of arguments which you use inside the call, correct? There are no types stated with names. So you don't give these names any values. Don't give these names any types, correct? Of course, correct? And then at any point of time, you can write a return. Usually, usually you write a return at the end, and you can return a value or not return a value, whichever way you want it, correct? And you can give default values to these arguments by saying something like def of f a equal to 1, b equal to 2, c equal to 1, d equal to 4, something like this, correct? So then if you do this, then the default value associated with, and you just say f empty, you don't specify the values, then it would pick the default values from here, correct? Correct? And yeah, so one thing about range that I wanted to tell you, so range I comma j is a sequence, or it is an iterable, but it's different from a list, like we said. It consists of, so if you do list of range I comma j, that will evaluate to a list consisting of I till I plus j minus 1. Sorry, j minus 1. Correct? And you can even give you can even say list of so you can also say range j, which gives you a list from 0 to j minus 1, correct? And finally, you can also say range of ijk, which gives you a list that starts at I, which gives you a iterable that starts at I, goes up till j in steps of k. So I plus 1, I plus j, I plus k, I plus 2k, and so on. It uses an arithmetic progression till you cross j. Correct? Till j becomes out of range. So till you cross j. And here k may be negative. So tell me, what would range of 0, comma minus 10, comma minus 1 give you? Tell me.
-9 to minus like 0.
So you would start with 0, then you would do -1, then -2, and the moment you cross -10, you reach -10, you stop. So it will give you 0 till -9. Correct? Correct? What
Yes.
would range 0, comma -9, comma -2 give? 0, comma -2, -4, -6, -8, and that's it. Correct? Am I clear?
Yes, sir.
Okay. Then just one more thing, that type conversion, like we said, that Python is a strongly typed language with dynamic types. So, but there are some exceptions to these rules, in the sense that if you do print x, x can be of any type, and it implicitly converts x to a string. And we will see how to do this implicit conversion in types that you define yourself. Later in the course, we'll see that. Correct? So that is via some some inbuilt function inside. Correct? So some function that you define inside. Correct? And similarly, string x converts x to string. And int x converts x to int. So this depends on the type of the value x contained in x. Correct? In some of the cases, if you say, for example, int something, it will raise an error. Correct? But if you say int 5.1, then it would give 5. Correct? Similarly, list iterable list x would give a list if x is an iterable. Correct? Otherwise, it would give an error. Okay. So tell me. So now let's just write the GCD function that we talked about earlier. Correct? And we will just quickly write it. So how do you write the GCD function? It takes two arguments, m and n. Okay. And now what do you want to do? You want to start from the larger of the two numbers. So this is also naive, but less naive than before. So you say val is equal to minimum of m comma n. Minimum is again an inbuilt function. So while val is greater than 0, so while val is greater than 0, if m% val equal to 0 and n% val equal to 0, if val divides both of them, then return val. Correct? And else you do val is equal to val minus 1 and that's it. Correct? And of course, if you might say that this else is needless, correct? You can just, instead of this, just say val is equal to val minus 1 and put it out of the this thing, correct? Okay. Okay. So that's all for today, and we'll talk later, correct?
So can you
Thanks.
scroll up just 1 second?
Yeah, tell me.
Just stop here. Okay. I just wanted to see. That's fine. Thanks.
Sir, can you scroll up a little bit more, sir?
Yeah, sure. Tell me.
Yes, sir. Sir, like, how did you define the F, sir? Like, I did not understand that part.
Which one? Which one? F. I did
Yes.
not define it.
Oh, okay.
I did not define it. I just gave a dummy definition, a header definition. And so I was telling you how to give default values to arguments, correct? Here. We will go into this in more detail next time. It's one of
Okay,
those.
sir.
Okay, don't worry about it too much. Okay. So that's all for today, and we'll meet on Thursday, correct? So any further questions? Okay.
Can you scroll down a bit?
Yeah, sure. Tell me.
No,
Tell-
not question, just last part of the code for that GCD. Yes, okay, thank you, sir.
Okay. Is there anything wrong with this? Do you see anything?
No. No, sir.
Okay. Okay, so I'll conclude the lecture now, and we will
Can you talk about that if else execution? Like if there is an else, then always the else is executed and if is ignored. Is it like that, or is it like from top to bottom? If
top
if
to bottom
statement.
if. It's a usual if. No. Of course, why should it be ignored? So only thing is that in the if you give a value that is false or 0 or an empty string or an empty list or none, then the if value is ignored. Then the if statements are ignored, correct? So I think so what I meant to say was that is the usual if else, correct? If this statement is true, these things are executed. Otherwise, these things are executed. That's the basic thing to remember. This is just a side condition as to what does a non-Boolean in an argument mean, in an expression means. Correct? Is this clear?
Okay, so those are like non-Boolean arguments, and that's why that if part was ignored and else was executed.
No. So, for example, if you say if so you say x equal to 1, correct? Now, if you say if x equal to 0, let's say, correct? If you say if x, then do something, print x. Else, print x plus 1, correct? So what would be printed? Tell me.
If x now, then you said that print x or else print x plus 1.
So it would try to evaluate this if 0 is like false. So it would not go in here. Instead, it would go here and print 0 plus 1, which is 1. So this should be executed.
Okay.
1 would be the answer, correct? That's all. So it's just some fringe cases that I am dealing with here, or main thing, depending on how you. So on the other hand, if you said if x was equal to 1, then what would be printed? X equal to 2, what would be printed?
X equal to 2.
So you would go here, check if x is true, and anything apart from 0 is true, any integer apart from 0 is true, so you would print 2. So this would be executed and 2 would be printed, correct?
Okay.
Am I clear?
Yes, sir.
Okay. Okay. Any other questions? Okay. So then we meet on Thursday. Thanks. Bye.
Thank you, sir.
Thank you, sir. Thanks.
Thank you, sir.
Thanks.